So I made an app that allows you to track all of your food using your voice, and it tracks all the macronutrients for you. This is just used to make my life easier when I want to hold myself accountable to stay on the top of my diet. So I'm going to show you an example of what this looks like. So here I have an open text editor, and I'm going to start dictating all the foods I had in a day. Today I ate 5 eggs, 100 grams of spinach, 50 grams of arugula, 2 ounces of feta cheese, 5 ounces of chicken breast, 3 slices of wheat bread, and 100 grams of almond milk. So I've had 5 egg, spinach, arugula, feta cheese, chicken breast, wheat bread, almond milk, and I've had just under 2,000 calories. I should probably eat some more, but I digress. The purpose of this series is to show you how to build this app from 0 to 1. Let's get started. Today we're going to go over how to build a proof of concept of the Track It app. That's the name I call that intro app that you saw. But the problem and the solution of this app start with this. The current problem is that you have to type, search, select every food you ate, and then choose the serving size for each food quantity before adding it to your food diary. So if you have 20 foods that you ate in a day, that's going to take you, 5 to 10 minutes to do all of the tracking and make sure you do it precisely. That can get tedious if you have to do that every single day. But I think a better solution is to take what you input as text or speech and convert that to an entire food diary list, which aggregates all of your nutrition data. I think that's more sustainable. I think it's a powerful solution, and I think it's worth building. So given the current problem and how tedious it is, and that we don't have a solution yet at our disposal to reference, it will be worth executing on this plan because it's exciting, it's new, it's challenging, and to create something as simple as a food tracking app that requires just your speech or your input text, that will require a lot of steps. But if it isn't hard, then everyone would be doing it. But by the end of this video, what you should be able to accomplish is to have written a script that takes text as input and outputs a list of dictionaries that you can use to query against a database to get all the nutrition data from. But we're not going to do any database stuff in this video. That will be in the next video. So let's get started. Before we start getting into the code, we need to understand what the goal of our project is. So we need to turn text into a list of foods. What is a food? It's a name, quantity, and serving size unit. For example, 5 ounces of chicken breast, 5 represents the quantity, ounces represents the measurement unit, and chicken breast represents the food name. How can these attributes be extracted from the text? This can be done by parsing the text, tokenizing each word by comparing it against a natural language processing model that infers what each word represents based on its linguistic features. Let's take, for example, today I ate 5 ounces of chicken breast. The string 5 has a part of speech that is associated with a number, and this can be used to denote a food's quantity. The string ounces is the serving size that comes immediately after the quantity but before the add position. The string of is an add position, which separates the quantity and the food being described. With this information, the food name, quantity, and serving size unit can be determined. How can multiple foods in a single sentence be determined? So we may have sentences that are as complex as, today I ate 5 ounces of chicken breast, 3 eggs, and 3 slices of bread. Essentially, we need to find an algorithm that will take each food from this text one at a time as we read it from left to right. So we need to parse each food in the sentence one at a time, looking at the quantity, serving size, and name. And when the 3 attributes have been obtained, add that food to the list and start the process over again with a new food. Repeat this process until the sentence is over. This is a very high-level algorithm, but surely the implementation will be a little bit more complex. But once you understand what the algorithm requires, writing the code is relatively straightforward. It's not a walk in the park, but I think understanding it makes coding a lot easier. Are there any edge cases in our algorithm? Well, seeing 3 eggs doesn't follow our pattern where there is a measurement unit. Clearly, there's no measurement unit here. It's 3 is the quantity, eggs is the food name, measurement unit is nowhere to be found. So we have to understand that there are some foods that might not have measurement units. And so based on that, we can infer that the quantity will be enough information to determine how many eggs we've eaten. But there's a point where if you don't know the quantity, you can't determine how much of the food name you've eaten. So we need to set some constraints on what constitutes a food. Do we need all three of these to constitute a food? No. What we can say is that the serving size unit is optional. Serving size unit is optional. So we may have foods that have no measurement unit. In the end, we want to run the program and test it with an example sentence. Before I start the project, I need to install all the requirements. So here I have a requirements file with Spacey, which is the module that handles all the natural language processing code, word to number, which will convert strings like 5, like the word 5, into a number that I can use, and URLi, which will suppress all of the warnings that you usually see when you install requirements. So first, what I'm going to do is I'm going to activate my virtual environment, install all of my requirements. Okay, everything has been installed. Clearly, I've run this code before, so it's already been satisfied. So go back to main.py, and here we are. This is some boilerplate code that will allow me to pass in an argument if I run this script. So if I say Python main, what it should do is print out the default text. So today I ate 5 ounces of chicken breast, and if I pass in an argument, today I ate nothing, it should show that. Okay, great. The next step is to actually write the logic that will handle taking this text, today I ate 5 ounces of chicken breast, 3 eggs, and 3 slices of bread, and give me an array of dictionaries. The first step is to write the algorithm. So what I'm going to do is write out an example of what I want this function to do. So the reason I want this is that this, first of all, breaks down this sentence into a list of token lists where I can get the number, the serving size, and the name. Number, name, number, serving size, name. So as you can see from the previous clips, that the measurement unit or serving size unit is optional. And here it's complaining that token doesn't exist. So let's create a type alias that is spacey.tokens.token.token. As you can see, we have our type alias, and we can now tokenize by quantity. So first, we need to actually break this down into tokens. So first of all, we'll create an NLP object, and we'll use the Spacey module and load the N core web SM. EN stands for English, core is the core. It's from the web, and it's small, so it's lightweight. It's not large, so we can actually use this and infer what tokens attributes are quickly. So next step is to say doc equals NLP text. So this will create a document from which we can iterate over, and we'll create a current quantity. We'll set it to none. Current tokens equals empty list. Current tokens total, which this will be our token lists. And we're going to iterate over all the tokens in the document. So first of all, we want to check if the token is a number. And the way we do this is we check if the token part of speech is of type num. Then we want to check if the current quantity hasn't been set. Then we set the current quantity to be the token.text, and we append this token to our current tokens. Otherwise, if we have a current quantity, then we want to append the current tokens that we've already aggregated. But we also want to make sure that the token that we're currently on is set into a new list. Otherwise, you'll lose out on this token. And then we set the current quantity to the token.text. Okay, this handles the case for when our token is a number. But what happens when it's a determiner? Well, first of all, we want to keep track of the determiner quantity. And if there is a determiner quantity, or if there isn't, then the current quantity is determiner quantity. And otherwise. Okay. The next step is that if our part of speech is punctuation and there is a current quantity, then we want to append the current set of tokens. We'll set the current tokens to an empty list, and the current quantity is none. Otherwise, if the current quantity is not none and token not in punct or correlative conjunction and token.text not in, this is for formatting issues when you input text with a new line, then the current tokens should get the token. And at the end, we want to return the current tokens total. Get rid of that empty list. So the next step is that I want to process all of my token lists into a list of dictionaries. So what I'll do is I'll create a function called process tokens to foods, and I'll pass in token lists, which will be of type list of token, and I will return a list of type dictionary. Okay, and so what I'll start with is I'll start with a foods list. This will contain all of the food dictionaries that I plan to create, and I'll need to have a reference to the quantity index because I know that the quantity index of my quantity token is going to be the first one. So I just keep a reference here. And I'm going to iterate over all of the token lists. And I'm going to set the index of the add position to be essentially the index for which a word like of would be located. So an example of today I ate 5 ounces of chicken breast. I want to find the index of so that every single word after of and every single word before it can be determined. So every word after of should be the food name and everything before it should be the measurement unit. So the quantity is going to be the get quantity from token list, quantity index. So this function isn't created yet, but the goal is to be able to get the quantity from that token because it could be text, it could be a word, it could be a float. So I want to have some abstraction over the complexity of getting the actual quantity. And I want to get the measurement type, or at least keep track of it here. And what I'll do is I'm going to create the food name tokens lower range. So that will be the index for which I'm able to get all of the foods after the add position. So if there is an add position, then the measurement tokens will just be the tokens from the token list after the first index up until the add position. And for measurement token, in measurement tokens, the measurement type is equal to the measurement token.text. If not measurement type, else measurement type measure. And the modified measurement type will be another function that we have to create. But the reason why we want to get the measurement type is that a can of soda, a can is a quantity and a measurement unit. But a can is a little bit too vague. So we need to convert can into 12 ounces, where 12 is the quantity and ounces is the measurement unit. So if there is a modified measurement type, then the measurement type is actually going to be the modified measurement type, the first index of that, and the quantity will be the modified measurement type at the first index, or at the second index. And the food name tokens index ADP plus 1, because we want the index right after the add position, if the add position exists. So in this case, by default, the food names tokens lower range, which is the index for which the food name exists, is by default at the index right after the quantity index. However, if there is an add position, that means that the food names tokens lower range will be whatever the index of the add position is plus 1. And so given this information, we're going to be able to determine what the food name is. Names tokens equals token list food names lower range up until the end of the token list. And we're going to go through each token and food names tokens, and we'll set the food name to equal the food name token if there is no food name. Otherwise, we'll set it to the food name plus the food name token text. And then we'll append the foods dictionary. So we'll say food name. We'll set the quantity and measurement type. And in the end, we just want to return foods. Okay, so we have this function, but we still need to implement the index of ADP, the quantity from the token, and get measurement list from text. So let's create our function get index of ADP. So get index of ADP, and we're going to pass in the token list, and we're going to return an optional integer. This will be our index. So in the example where we can't find the add position, we want to return none. So we'll go through all the elements of the token list up until the last one, and if token list part of speech is an add position, then we'll return the index. Otherwise, we'll just return none since we couldn't find it. So now, got that function, let's create our get quantity from token. And we'll return an optional float. Since we can have 0.5 ounces or 0.25, so we want to make sure we return a float. And if the part of speech is a number, then we want to try, since we're going to be using the word to number module. to get the number from this token text, if it's possible, because this thing is a throwing function. And if we get a value error, then we will just return the float of whatever the token text is. Elif token, if it's a determiner. Oops. Then we want to try determiner to quantity token.text. Otherwise we'll return none, and we'll return none if the token doesn't follow any of these patterns. The last function we need to implement is get measurement list from text. So here I have copied and pasted a mapping between the measurement type, which could be can, bottle, liter, serving. You can add to this list. It's infinite essentially, but for the sake of this proof of concept, I want to be as simple as possible and cover some of my bases. So essentially this will convert a measurement type into a measurement unit and a quantity. And with that said, I'm going to modify my main function, and I'm going to process tokens to foods, tokenize by quantity, and pass in my input text. And I'm going to run my script. And as you can see, we have exactly what we're looking for, a list of food objects. We got chicken breast, 5 ounces, eggs, 3, measurement type none, exactly like how we predicted earlier. And we have the last one, which is bread, quantity 3 slices. Congratulations for making it this far into the video. If you followed this tutorial and you found it helpful and you learned something new, please leave a comment and a like, and subscribe if you haven't already, because the next video I'll be doing will be going over how to set up and preload a database with food data so that you can query against it given this list of foods that you've gotten. So I'm looking forward to seeing you then.